either to find the price of it, or given the price, find the rate of return that we're promised on the bond. Okay? We're going to constrain our discussion in this class to what we generally call plain vanilla bonds. These are going to be just straight fixed rate bonds that are pretty easy to calculate its price or rate of return on. Right? As long as you're comfortable with the time value money stuff from chapters 3, 4, and 5. If you guys are struggling with that stuff, go back and pick it up right now, because the next 2 chapters are going to leave you behind in a hurry if you're not comfortable with that. But everything we're going to do for the rest of the class is really just an application of what you've got so far. There's not really going to be anything new. With bonds, what we're going to find is that we already know how to do all the calculations. What we have to learn now is the vocabulary associated with bonds, because it is old, it is rich, and it is dense. When we describe something on a bond, unless you just happen to work with these every day, it's not obvious what we're talking about. Okay, so we'll spend most of our time struggling with the vocabulary. Once we get that down, we'll figure out the calculations or something we already know how to do. All right, so let's start there to make sure we're all on the same page. So we're going to throw some definitions out. We're going to look at, let's see what I have written down here, something like 8 definitions and then a couple of tips before we actually dive into problems. All right, but let's start with what exactly is a bond. Can someone tell me in English terms, like not in finance terms, what is a bond? How does a company use a bond? To buy stuff?
Buying and selling.
Buying and selling bonds? Okay. So say that again.
To bail you out of jail.
To bail you out of jail. Okay, different kind of bond. So they have some similarities though. So if a company sells a bond, what do they get in return? They get money in return, right? And when they get that money, what do they promise to do when they sell the bond? To pay it back, right? So in your life, if someone gives you money and you promise to pay it back over time, what do we call that? It's a loan, right? A bond is just a loan. All right, that's all it is. This is one way for companies to borrow money. They can go to a bank and take out a regular loan, just like you and I can. But when you want to borrow tens of millions or hundreds of millions of dollars, there's not a lot of banks that are just going to extend you a line of credit for that, right? A bond is something that you can sell to investors on capital markets. I can go and buy a bond from Coke or IBM. And when I purchase that bond, I give the money to the company, and they promise to pay me back over time, principal and interest. So it's just a loan. It's a way to raise large amounts of money in capital markets. All right, so take some of the mystery out of bonds. Funny name, simple concept. All right, let's talk about some of the stuff associated with bonds. The first is the maturity date. Okay, the maturity date is just the date of final payment on the bond. Right, so just like your car note or your lease contract or something like that, you specify a set number of payments you're going to make, and once you satisfied that contract, you're done. Right? And we call that the maturity date on a bond. Okay, associated with the maturity date is something we call term. I'm going to try and write that in English one more time. There we go. Okay, the term is just the time remaining until the maturity date. Right, so if there's 5 years remaining until the maturity date on this bond, the term of the bond is 5 years. Right, so just how much time is left. All right, face value of the bond. We're going to have a funny textbook definition first. All right, this is the notional amount used to compute the coupon interest payment. Okay, this is the principal of the loan. It's the amount that's promised to be repaid at maturity. Bonds typically work a little bit differently, at least the ones we're going to look at, than a consumer loan that you're familiar with. When you make a payment on your car note, a little bit of it is interest and a little bit of it is principal, right? Every payment you make has both of those components inside of it. Same thing on a mortgage. Bonds are interest-only loans. The payments that they make periodically are interest-only, and at maturity, all of the principal is due at one time, right? And we call that the face value of the bond. And we're going to use that amount to calculate the coupon interest payments. Usually, this is $1,000. But it can be any amount. For example, $100,000 face value and $200,000 face values are common.
So 100,000 and 2,000?
And 2,000, yeah. So it's important to note what this is not. This is not the price of the bond. This is not what you can buy and sell it for. This is a notional amount set in the contract that's usually promised to be repaid at maturity, and it's only used to calculate the coupon rate, or calculate the coupon payment.
So basically, you say that if you this $2,000 back, this is what you said?
No, the cash flows are a little bit different than that. And we'll get into that. We'll map out a timeline of these. You're going to give them some amount today that's going to be the price of the bond. And if the face value is $100,000, they're going to promise to repay you $100,000 at the end. You're going to have to decide how much you're willing to give them.
Okay.
There won't be a set price by contract with these. It's set by the market. Okay, the coupon rate. This is a percentage of face value that the bond pays each year. This rate is set in the bond contract. Well, actually, I'm not going to add that second part. All right, so this rate is set in the bond contract. The market doesn't get to choose this rate except for indirectly. When the bond is first issued, once the bond is issued and the contract is in place, that coupon rate is set. Right? And I'm going to put a note here that won't make a lot of sense right now, but when you go back to your notes, it's going to be helpful. Right? We will never use this as the discount rate to find the price of a bond. All right, so never use this as the discount rate to find the price of a bond. The only thing we use the coupon rate for is to calculate the coupon payment. Bless you. Actually, let's add that. Let me back up and add that to your notes too, so you have to go back. It's only used to find the coupon payment. And that gives us a nice segue into the coupon payment. The coupon payment is the promised interest payment on the bond. Okay, and this thing has a set definition. The coupon payment, the text and a lot of other places abbreviate it CPN for coupon. This thing is equal to the bond's coupon rate times the face value, all divided by the number of coupon payments per year. All right, we're almost there, y'all. The price of a bond is exactly what you think of as a price. This one's not too confusing. This is what the bond can be bought and sold for. The price of the bond is set by the market. Not by the bond contract. And all the stuff that we talked about before, we put a note in there, the coupon rate and therefore the coupon payment are set in the bond contract. The face value is set in the bond contract. The price is not. The people who are willing to buy it and sell it are going to negotiate with each other and set the price of this bond. Tied to the price and the other cash flows of the bond are what we call the yield to maturity. Or YTM for short. And I'm going to give three different definitions to the yield to maturity. All are equivalent. They all say the same thing, but they look at it from slightly different angles. All right, and one might ring a little more true for you than another. All right, the first one for the yield to maturity is one we're sort of familiar with. This is the rate of return on the bond if, okay, and that's a big if, the bond is purchased held to maturity and all coupons are reinvested at the yield to maturity. All right, so that's a lot of stuff that's got to happen. But if all that happens, if you buy the bond, hold it until the final payment, and you're reinvesting those cash flows back into the bond, or at least into something else that has the same rate of return, then this will be your rate of return from holding the bond. Another way to think of the yield to maturity is this thing is the discount rate. That equates the price of the bond with the promised future cash flows. That is, the coupon payments and face value. Hey, I said three definitions. Really want to go with those two. The third one's more a characteristic of the yield to maturity. And that is the yield to maturity is expressed as an APR with appropriate compounding. Okay, three relationships to keep in mind, and let's walk back up to the face value. The fourth definition, I'm going to add in there the face value is aka or also known as par value or principal, which we have in the definition, but then we've got them both in the same place. All right, so face value, par value, and principal, all three of those terms will be used interchangeably when we're talking about bonds, because finance folks like to make things confusing. All right, so those are really sort of the vocabulary associated with bonds that we're going to have to be able to unpack to map out these cash flows. Once we can map out the cash flows of a bond, we're home free because we know how to do everything else. There are three more common phrases that I want us to know associated with bonds. Okay? And they have to do with describing the price of a bond and how it's trading. The first one is, you'll hear folks say a bond is trading at par. And anyone already read ahead and know what trading at par means?
Trading at face value.
Yeah, it's trading at face value. So the current price is equal to the face value. Right. Remember all that stuff we talked about with bonds, the price, the coupon rate, the face value and the coupon rate, the maturity, all of that is set in the bond contract. The only thing the market gets to choose is the price and the yield to maturity. And these two are inextricably tied together. Right? As the yield moves, the price moves. As the price moves, the yield moves, and in a specified relationship. So a bond is trading at par. This has to be true. It must be true that the yield to maturity, so let's be more specific. Let's say it'll trade at par. This is true only when the yield to maturity is equal to the coupon rate. And that'll make more sense as we start looking at some examples. But this relationship will be helpful to have your notes and go back and look at. All right, so talking about trading at par, that's where the price is equal to face value. There are two more possible conditions, right? Price is less than face value or price is greater than face value. Trading at a discount means that the current price is less than face value. So the current price is less than face value. This is only going to be true when the yield to maturity is greater than the coupon rate. And when we look at the cash flows, this will make some sense, right? Because the bond's promising to pay 10% as a face value of $1,000, but you can buy it for $800, then you get to buy it for less, so you're buying it at a lower price, but you're still promised a 10% rate of return on the bond, right? Or you're still promised 10% rate of interest on the bond. If the price is $800, you actually get some capital gains built into that as well when you get your $1,000 back. So you're going to earn something greater than 10%. Your yield to maturity will be greater than your coupon rate. All right, trading at a premium. Anyone got a guess? Current price is, yeah. All right, what about the relationship between yield to maturity and the coupon rate?
It'll be less.
It's going to be less than, yeah, you got it. And so the bond's coupon rate is 10%. It's promising a 10% interest rate with a $1,000 face value, but the cheapest price you can buy this bond at is $1,200. You're paying higher than face value, so your actual rate of return is going to be less than 10%, what it's offering in the contract. Okay, so that's an awful lot of terminology getting thrown out at once. So you guys have any questions, any points of clarification before we start applying this and looking at problems? All right, let's look at some example problems then. We're going to look at number 4 from the Chapter 6 homework. That's problem code 6-5. Let's see, there's enough going on with bonds. I'm going to pull up the example problem so you guys are looking at the same numbers when you go back to study later. All right, we're going to start with the simplest kind of bonds. a zero coupon bond. All right, not so creatively named. It tells you exactly what the deal is. A zero coupon bond means that it pays no coupon. The only cash flows with this bond are the purchase price, right? Whatever you buy it for today, and then the face value returned at maturity. Right, so it pays no coupon. The only cash flows are the purchase price and then the face value returned at maturity. Okay, now bond prices are funny critters. Remember I said the price is what you can buy and sell it for today, but the notional amount, the face value, it could be $1,000, it could be $2,000, it could be $100,000. So when you see bond prices quoted, either if you go to a dealer to purchase a bond, you can look them up in the Wall Street Journal or on Bloomberg or something like that, what you're going to see is a bond price quoted either per $100 of face value, or they're just going to give you the yield to maturity. Because with the yield and the face value, you can calculate the price easily enough. Right? So most bonds are just compared in terms of yield or price per $100 of face value. All right? So we need to be able to unpack some of this information knowing that. All right, here's the setup for number 4. Is that all of it? Yeah, that's all of it. Hey, it says the zero coupon yield curve for risk-free bonds is as follows. On the top, we've got maturity in years, 1, 2, 3, and 4, and then YTM, or yield to maturity, for each one of those. And it asks, what is the price per $100 of face value for a 2-year, zero coupon, risk-free bond? Okay, so the yield curve. What we're looking at here is we actually have 4 different categories of bonds. The 1-year maturity matures in 1 year. So if you were to buy it today, your money would be invested for 1 year and you would get the face value back 1 year from now. The 2-year bond, you would buy it today and you would get face value back 2 years from now. The 3-year bond, you buy it today, get your money back 3 years from now, and so on. All right? It's asking you for the price per $100 of face value for a 2-year, zero coupon, risk-free bond. It already told you this is the zero coupon yield curve. So what we want to know is the price per $100 for a 2-year, zero coupon, risk-free bond. All right, what it does not tell you, it doesn't tell you the face value. I have no idea what it is. Could be $1,000, could be $2,000, could be $100,000, could be $5,000, who knows? All right, it tells us that it's a risk-free bond. So that tells me that this is going to be a treasury security, and treasuries have a $100,000 face value, and you'll know that when you start working with bonds a good bit. But it wants to know the price per $100 of face value. Since I'm looking for the price per $100, what I'm going to do is pick a face value of $100. Because it doesn't matter what the face value is. Everything's in terms of percentages, so I can pick whatever I want. All right, so that's exactly what I'm going to do. Since it wants the price per $100 of face value, I'm going to use $100 as the face value. And that's going to simplify my life. If I chose a face value of $100,000, which I know this probably has, I'll get the price per $100,000, and then I'm just going to have to convert it to per $100. So I have to take another step. So I'm going to simplify my life and not do that. Okay, let's map out the cash flows of this bond, knowing that we're going to use $100 as the face value. All right, we're looking for the price on a 2-year bond, so my timeline's going to have 2 periods. I'm looking for the price today. That's what it wants to know. I would buy it for some price today. This thing is a 0 coupon bond, so there's going to be no payment next year. But at the end of the 2nd year, I'm going to get the face value back. All right, if I were to buy it today, I would receive $100 in 2 years. So I'm going to pretend I receive $100 in 2 years. Okay. And the question is, how much should I be willing to pay for this? Well, all that's really asking is, what is the present value of $100 discounted back to today's dollars using the yield to maturity for a 2-year bond? Right? And that's given to us in the problem as 5.6%. Right? And remember what yield to maturity is. This is the rate of return for holding the bond, right? Or it's the discount rate that equates the current price of the bond with the promised future cash flows. Right? This is just a lump sum time value problem, right? So the price of the bond today is equal to the face value discounted back to today's dollars using a lump sum present value formula. All right, so for this bond, the future value is $100. That's what I would get paid in 2 years. The yield to maturity is 5.6%. So plugged in as a decimal, that's 0.056. And I'm going to receive that 2 years from now. So if we plug that into the calculator, we've already got the answer up there. We should get something awfully close to $89.68. That formula works great for this one. It's a one-step simple problem. If you're wanting practice with the time value keys, you can use that as well, where the number of periods in this problem are 2. Your discount rate, which is your yield to maturity, it's 5.6%. Present value is what you're looking for. Payment is nothing. We get no periodic payments off of this bond. And the future value is 100. And if you put in a positive 100, you should get back a negative 89.68 or something really close to it. Okay, so I'm hearing murmurs. Is that because you guys are bored and this is too simple, or are you not coming out okay? All right, we're good? No, I'm not getting on to you. I just want to make sure we don't have anything to declare. We good?
We're good.
Okay. All right, so some things to note since we're looking at 0 coupon bonds. There's no coupon payment on a 0 coupon bond. So the only source of return for the investor is capital gains. That is, you need to get back more than you paid for the bond. All right, so the only source of return on a 0 coupon bond is the difference between the purchase price and the face value. Okay, so thus zeros, which is short for zero coupon bond, zeros always trade at a discount, right? Always. If I'm going to be induced to purchase one of these bonds, the only rate of return I'm going to receive, the only way I get any sort of money out of the investment, is if I receive more than I paid for it. Because my money's locked up in this thing until I can sell it or get the face value back. Right? Imagine if so Treasury zero coupon bonds are one way that the U.S. government borrows money. Right? Imagine if they came to you and said, hey, have I got a deal for you? For the privilege of lending the United States government money, you pay me $110,000 today, I'll pay you $100,000 back in 1 year. Right? Anybody taking that? No, of course not. Right? Why are you going to pay the government to hold on to your money for you? Right? They're earning a 10% rate of return on your money. So the market forces these to always trade at a discount. Right? It's the only source of return there is.
Always trade at zero bond, whatever these called, zero coupon bond.
Zero coupon bonds always trade at a discount. Yes, ma'am. Right, and what does a discount mean? Current price is less than face value, yeah. So if you go to calculate the price of a zero coupon bond and you come up with something higher than face value, you know something's gone wrong. That can't be right. All right, what about, let's see, I didn't put an example of this in my notes, but surely we've got one. Last one. If there's no one in there, that's why I didn't put an example in my notes. Okay, that's all right. We'll get to play with the coupon bonds and see this working. No big deal. So you guys okay with this example? Pretty easy, right? Okay, let's have a little bit more fun. Uh-oh. Let's look at number 9. Okay, number 9 is our first coupon bond. This one's actually going to make payments. And let's see. Let's look at the example. So, got the same numbers to look at. Okay, setup for this thing is suppose a 10-year, $1,000 bond with a 9.2% coupon rate in semi-annual coupons is trading for $1,000.38. What's the bond's yield to maturity? It gives you a hint there, expresses an APR with semi-annual compounding. And if the bond's yield to maturity changes, what will be the bond's price? Okay. Let's first unpack this so we can then put these cash flows onto a timeline and figure out exactly what it's telling us here. All right, so it says suppose a 10-year. What's it telling us when it says 10-year?
How many years of term?
Yes. So we've got 10 years until maturity. When it says it's a $1,000 bond,
Face value?
that's the face value. That's exactly right. All right, what about when it says 9.2% coupon rate? What's that telling us?
Percentage of the face value that they each year.
That's exactly right. That's the coupon rate. So that's the percent of face value paid each year. Okay, and just a note here, it says specifically 9.2% coupon rate. A lot of times you're going to see it written just 9.2%. They'll just say it's a 9.2% bond. Okay, and it's on you to know that it's being quoted as the coupon rate. If it doesn't say otherwise, it's the coupon rate. All right, I'm going to be a little bit more clear in that for folks that aren't here. It'll often just say 9.2% bond and it won't specify coupon rate. See. Hey, what's it telling us when it says semi-annual coupons?
Maybe done twice a year.
Yep. Let me say makes coupon payments twice per year. Okay, and finally it tells us it's trading for 1,038. And that's telling us the current price. No real mystery there. Okay, from all that information, we can pick out one more thing that it didn't directly tell us, and it never will when you're looking at a bond quote. Right? And that is the actual coupon payment. Right? That CPN, which we're going to need in just a moment. That actual semi-annual coupon payment it's making, the dollar amount is given by the formula coupon rate times face value divided by the number of coupon payments per year. All right, so for this bond, it's a 9.2% coupon rate with a $1,000 face value. So to find that, we're going to take 0.092, that's 9.2% expressed as a decimal, times the face value of 1,000, and then divide that by 2. So that's 92 divided by 2, so 46 even, right? All right, so let's take all of that information and drop it on the timeline and look at the actual cash flows from this bond. All right, this thing's a 10-year bond with semi-annual coupons. So you saw the mistake I just made. trying to get 2 steps ahead of myself. There's actually going to be 20 periods on this timeline. All right, 10 years, but making payments twice per year. All right, I'm going to draw out a generic bonds timeline from the perspective of the investor. From the perspective of the investor, you're going to pay the price today. So I'm going to have a negative P at time period 0. And then you're going to receive coupon payments for 20 years. Okay, so starting one period from now, 1 6-month period from now, up to and including the 10th year. And then along with that last coupon payment, you're going to get the face value back from the bond. So if we plug in the actual amounts from the bond in this problem, still some price today. We don't know what that is. The coupon payments we receive every 6 months are $46. We get 20 of those, and along with the last coupon payment, we're also going to get the $1,000 face value back. Oh, whoops, sorry, for this one we're not looking for price. We're given price, aren't we? Jumping ahead of myself to part B. We know the price is $1,038, so we'd have a cash outflow of $1,038 today. We'd receive those 20 coupon payments and then also get the face value of $1,000 back 10 years from now. And part A asked us, what is the yield to maturity? Right, so that is what discount rate takes all of these cash flows and equates them back to $1,038. We'll check out what kind of cash flows we have here. This $46 payment. Right here. It starts one period from now and then happens at regular intervals and then stops 20 periods from now. What kind of cash flow is that? What do we call it? It's an ordinary annuity. Right? We have a formula for that. Right? When we already know the price of it, so we can use the present value of an annuity formula and solve for the rate that makes it true. Right? What about this $1,000 right here? That's just a lump sum 20 periods from now, right? We have a formula for the present value of that too. It's just the value divided by 1 plus the discount rate raised to the n. Well, if we combine those two things together, we get the formula for the price of a bond. All right, where it's just the coupon rate before that was cash flow in an annuity, divided by Y for yield to maturity. All right, so we're just using a Y instead of an R. And then that's times 1 minus 1 over 1 plus your discount rate raised to the n. All right, that's the present value of an annuity formula. Nothing new there. And then we're going to add to that the lump sum at the end. So the face value divided by 1 plus y to the n.
And what's the formula? You said that's the present value of annuity?
This is for the price of a bond.
Okay.
Right, but the formula is one we've seen and used before. It's just the present value of an annuity. Right, this first part of it. And the second part is just the present value of a lump sum. And we had so much fun with those before, we're ready to use them again, right? Mm-hmm. Yeah. Well, I have good and bad news for this one. Let's plug in to this formula what we already know. For this bond, we know the price. We know it's $1,038. We know the coupon rate, all right? That's $46. What we don't know is the yield to maturity, so I'm going to leave that as the variable y. All right, and that's times the quantity 1 minus 1 over 1 minus y raised to the 20. We know the number of periods.
Shouldn't be 1 plus y?
Yes, 1 plus y, thanks. We also know the face value. And that's raised to the 20. Okay, so all we've got to do is find the y that makes that statement true. All right, does anybody remember how to do that from algebra?
Is it y over one?
I'm sorry? Yeah, so we need to get all the y's together, right, and have them just on the left side of the equation, have all the numbers on the right side. Here's the thing. We've got a y to the 1 right here. We've got a 1 plus y to the 20 here, and a 1 plus y to the 20 right here. Once we get over about an exponent of 4, we can't solve this anymore. There's no algebraic manipulation that's going to let you solve for y. You can't do it. The only thing you can do is what we call iterate. That is, guess at that. You look at it and go, well, it's trading at a premium. All right, so I know the yield to maturity has to be less than the coupon rate. Coupon rate's 9.2%. Let me try 9% and see if that works. And if 9% doesn't work, you adjust your guess and go again. And you just keep going and keep going and keep going. You iterate that guess over and over again until you get close enough. That sounds fun, right? So we can't use algebra to solve this. We have to iterate. That is, guess over and over.
I thought you were going to give us that way to do it.
All right, so we can't use algebra. We have to iterate. That is, guess over and over until you get close enough. Okay, now here's the good news. That's the bad news, right? Solving that by hand is a massive pain. Turns out, like a calculator or a computer is a really, really fast guesser, right? It can plug in an answer, try it, doesn't work, adjust its guess, and go again. So your financial calculator, if you're using the BA2 Plus or if you're using the one in My Finance Lab, can do this very quickly for you, right? It can iterate. It doesn't have a magic formula that solves it, but it can guess really, really quickly, at least from our perspective. So we want to use the time value of money keys for this one. Yeah, that's what I'm talking about. All right, entering bonds into these things takes a little bit of practice, though, because there's some little quirks with them. All right, N already filled in. It's 20. Remember, N is the number of periods or the number of payments if we're talking about annuities, so that's 20. What's my I over Y? We don't know. That's the discount rate that we're looking for. God bless all of you. All right, what you're going to be tempted to do is use the coupon rate, that 9.2%, because it's a percentage, right? We plug a percentage into I over Y. Never, ever, ever will we use that as a discount rate. All right, never. The yield to maturity is your discount rate, and in this problem, that's what we're looking for. So fantastic. Okay, present value. What are we going to plug in for that?
1,038.
1,038. Okay, what about our payment? 46. And future value?
1,046. Is it 46 plus 1,000? 0?
Yeah, so this is the quirky part. We're going to plug in 1,000. All right, and this is a quirk of how your calculator works. When you plug in 46 as payment and you set in to 20, what you tell it is I'm going to receive 20 payments of $46, and your calculator assumes that's happening at the end of the period. If you then plug in an additional value on future value, it assumes that is in addition to that last payment that you put in. All right, so it's adding those two together for you already. You are absolutely right in thinking that what you receive is $1,046. That's what you get when you buy the bond, right? But your calculator's adding those together for you. What are you guys getting when you put that in? An error message, right? Yeah, let's talk about that. All right, let me guess. You're getting error 5.
Yes.
Has anyone already broken one of their calculators in frustration and know what error 5 means? No. Yep.
Do you make the present value negative?
You can either, so you have two ways to go with this. All right, this is not something we've talked about very much because it didn't really matter in the previous chapters. I mentioned that your calculator uses that cash flow sign convention to keep track of the direction of cash flows, right? If we enter all of these as positive, so I tell the calculator I'm going to receive 1,038 today, I'm going to receive 20 payments of $46, and I'm going to receive an additional $1,000, what's my rate of return on that? Those are all cash inflows. Your rate of return is infinite. Right? So your calculator says, that doesn't make any sense. Error 5. Right? I can't do that because what you just asked me to do is nonsense. All right, so we need to tell it the direction of the cash flows. You can either pick the perspective of you as the bond purchaser or the perspective of the company selling the bond and make sure you track the direction of those cash flows. If we take the direction of us, the bond purchaser, which if we look back at the timeline, that's how we laid it out, we'd have a cash outflow of 1,038. I'm going to rewrite it because I want both of those on there for folks that look at it later. You, of course, don't have to do that. So negative 1,038 is a cash outflow, and then I would have cash inflows of 46 and 1,000. Now what are you guys getting? 4.33? 4.3126, 4.313. So what you guys getting? Okay.
I just rounded up.
Yeah. Just so we're clear on this, you'll get you're going to get the same right answer if you work this from the perspective of the company issuing the bond. Right? From the perspective of the company that sells the bond, they receive your 1,038 today, and then they have cash outflows of 46 and 1,000. Right? So if you make the present value positive and the payment and future value negative, you'll get the same right answer. Right? It's the exact same question, just from a different perspective. Either way will work fine.
So what we just found was part A, right? The Y?
Not quite yet. Not quite yet. But yes, we're working on part A. All right, so that's 4.3126%. Remember what your calculator's doing for you. That N is every 6 months, right? That payment is every 6 months. So what is that interest rate? It's every 6 months, right? That's 4.312%, 6% per 6 months. Okay, yield to maturity is expressed as an APR with appropriate compounding. And we're way back in chapter 5. That APR is equal to R times N, where N is the number of compounding periods per year. So our APR is equal to, doesn't matter in this case if you do it as a decimal or a percentage. And so it's that 4.3126% times 2. It's paying semi-annually. We have 2 periods per year. So that's what, 8.61? 0.62, yeah. All right, and then that's your final answer to part A.
Will you round it up? I got 8.6252.
8.6252?
Yeah, why not?
2.12. Oh, yeah, because that 6 is going to load onto the 2. That is going to go to 5. So 8.63. You're right. All right, so just to point out, we've been talking about this problem for what? I don't know, 15, 20 minutes, something like that, right? But let's go back and look at what we actually did. All right, we were given all this information. It's a 10-year bond. Coupon rate is 9.2%. Current price is $1,038. What's the yield to maturity? All right, and all we did was calculate the coupon payment. Always, 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 I'm telling you guys, it seems worthless now, but draw that timeline. Draw it out on the timeline. Make sure you get the cash flow straight. And then you plugged it into your calculator to get the yield to maturity. That's it. It's a one-step problem. You just got to get the information to plug into your calculator. Okay, so this one goes pretty quick. Okay, any questions are coming up with that number, though? You guys punching buttons, getting it okay? Yeah? Okay. Let's look at part B, and I'll actually go to a new page for that. Part B, yeah, that was just part A. It was one step, right? We spent a lot of time explaining it because this is your notes, but it's a one-step solution. You plug it into your calculator, you're done. Right? All you have to do to solve this problem is this right here. This is it. Why are you not writing? Right? That's the solution to part A. All the rest of the stuff was just, this is why you're doing what you're doing. And please go back and spend time with the why part. Because what's going to happen is you're going to be in my office the day before the test. You're just going to be punching random junk into your calculator and have no idea what you're doing. And you're not going to be getting the right answer. So if you spend a little bit of time on the why, like spend an hour looking over that, the bond problems are going to be no problem for you at all. You can be working in one step with no mistakes. Oh, my gravy. What problem are we working on again? Number 9. All right, part B. What's the taskmaster going to ask of us in part B? All right, if the bond's yield to maturity changes to 10.5% APR, what will be the bond's price? And everything else is going to stay the same. The coupon rate, the face value, the term to maturity, all of that is set by contract and cannot vary without the bond going into default. But the yield can change, and it changes with the price. The market's constantly changing those. All right, now, what did we figure out? Let's go back before we start working this. We figured out the bond's current yield is 8.63%. Right? That's the current rate of return on the bond. Go back up here and look at the bond price formula, this guy right here. That Y that we solved for was 8.63%. Now it's going to go up to, what was it, 10 point something, right? 10.5%. if each one of these guys goes up, that y in the denominator goes up, this y in the denominator goes up, this y in the denominator goes up, what direction is the price going to move?
Down.
It has to go down, right? It has to go down. Every single one of those y's are in the denominator. We make the denominator larger, we're dividing by a bigger number, we're making the overall quotient smaller. All right, that is a truism with bonds. If yields go up, prices go down. When yields go down, prices go up. Always. Okay, for bonds, that's just math. Since those future cash flows are fixed, when the yield changes, the price changes in direct opposite relation to it. All right, so they're inversely related. So for this problem, we're going to recalculate the price, and we're expecting it to be something less than 1,038. All right, so the yield's moving to 10.5% from 8.63. We're expecting the price to fall. In fact, before we even start working the problem, we can say something else. The yield is 10.5%, right? And the coupon rate is equal to 9.2%. Okay, so the yield is greater than the coupon rate. What then do I know about the price? It has to be trading at a discount. So I'm expecting a price something less than $1,000 when I go in and calculate this. And that seems like extraneous stuff that's just, ooh, the nerdy professor like to point out how all this is interesting from different angles. Spend some time thinking about this, right? And thinking about the relationships between yields and prices and bonds. And these problems are going to start going really, really fast for you when you start investing some time and thinking about those relationships. Right, so it's not something after a while you're going to have to like draw pictures and think through really hard. You're just going to know, right? It's going to be there because you've thought about it already. And you'll make far, far fewer mistakes. Okay. So what's going on with this problem? For the sake of consistency, I'm going to map it out. You've actually already got this one mapped out. We'll see it hasn't changed all that much. All right, coupon payment is still $46. We get 20 of those guys. We're still getting $1,000 back at the end. The question has become, what is our new price, given that we are now discounting each of these cash flows back at 10.5% instead of 8.63. Okay, for this one, we can use the formula or we can use the time value keys.
Why would you ever use the formula? I'm just curious.
No, fair question. I force you guys to use the formula for the first 4 chapters because until you see how those numbers are relating to each other and moving, you have no idea what your calculator is doing for you. Right? And I've just had too many students in my office punching buttons and just randomly putting stuff in the time value keys, not having any idea what's going on. So I think that's where the usefulness of the formulas go. You get used to, when I increase the interest rate, what happens to the present value? right? You get used to seeing those relationships, and it makes the problems easier to think through. If I'm working these problems now, the calculator is a tool that frees me up to think faster, so I'm always using the calculator. I had a computer science major in the spring in the class that never touched his financial calculator and worked the problems faster than I could with the calculator. So some folks just get pure joy out of watching those work. I don't know. Okay, so if we're plugging this in, N is still 20. I'm going to leave blank for a second. Price is what we're looking for. Payment's still 46, and future value is still 1,000. I'm going to leave this as the perspective of my pocket, so I'm going to enter payment and future value positive. All right, the I over Y we need to talk about for just a second. And let me look and make sure it really is 10.5. Yeah, 10.5, okay. All right, so the yield to maturity expressed as an APR is 10.5%, right? So that's my annual percentage rate. I've got a semi-annual bond, 6-month periods. Can I plug in an APR to I over Y? No, I'm using an annual rate for payments that are happening every 6 months. What do I have to do to this thing?
I mean, divide by
By the way, divide by 2, right? Yeah. So I'm given the APR, right? That's equal to my periodic interest rate times N. What I always plug into that I over Y is R, right? And that's APR over N. Never opened my calculator. That's right. You guys already typing that in? All right, when I type in, if I have to do division going into I over Y, what I'm going to do is have the calculator do the division for me. And once that number is on the screen, I'm going to press the I over Y key. So it uses that full 13 decimal version. So I'm going to do 10.5 divided by 2 equals, this one's going to come out even, they don't always. While that's on the screen, I'm going to press I over Y. And if that had more than 4 decimal places, that would have minimized my rounding errors. Present value is what I'm looking for. 46 is payment, and 1,000 is face value. Compute present value. All right, of course, it's going to give me a negative 920 and change. That's just telling me that if I wanted to earn 10.5% APR, I should expect to pay $920.69. All right, and that's it. So part B is a 1-step or 2. All right, once you know the why behind it, you can just plug into the time value keys and rock on.
So just say monthly divide by 12. Instead of semi-annually, if it's monthly.
Yes, ma'am. Good point. So yeah, if you're receiving payments monthly on the bond, you divide the interest rate by 12. Yep. Yeah, and if it's making payments annually, then the APR is the same as the periodic effective rate and no adjustment needed. Yep. All right, so we okay playing with coupon bonds now, finding prices and yields? Y'all are so excited about bonds. Okay. Well, let's talk about credit risk, and then we'll be done with these guys. You'll have seen everything you need to go in and work the homework problems for these. Bonds are pretty straightforward. Up until this point, we've assumed, and I've actually said, that you know exactly how much you're going to get paid on a bond. You know exactly when you're going to get paid. In reality, companies don't always make their bond payments, right? They get into financial trouble just like you and I do, and they have trouble paying their debts. Okay, so there is credit risk associated with bonds. And let's actually, just to make this go a little bit quicker, I'm going to look at it with a PowerPoint. All right, so really I just want you guys to have an idea of how this works, right? And so we're not necessarily writing down in the notes. All right, so U.S. Treasury securities, that's our federal government borrowing money. Those are considered risk-free, right? And they're considered risk-free because the federal government owns a printing press. If they run out of money, they just print some more, right? And they'll give it to you, right? So you will receive your promised interest payments on a bond. All that junk that you hear about, oh, the U.S. government's going to default and all that, there's some debate amongst legal scholars if they're even allowed to do that. The Treasury, it appears, is required by law to make those payments. So if they run out of cash, they print more and pay the debt. Hey, it's probably what will happen if we ever decide to default. We'll see. I don't know. We hadn't done it yet. So that's open to a little bit of debate. But you're going to receive your payments. There's just no guarantee how much those dollars are worth when you actually receive them, right? But you will get the promised payments. When we talk about credit risk, that's the risk of default. That is, you won't get paid either in whole or on time. Your payment can be a little bit late, and that's still considered a default. Corporations don't own a printing press, so there's default risk there, right? Even the best managed companies in sound financial health can run into problems, right? Kodak is a classic example. They were one of the highest rated, most financially sound companies on the planet in 2005. By 2007, I think it was, my timeline's probably a little off, they were bankrupt. They were gone. Does anyone know why? iPhones, right? Nobody needed film cameras anymore. Everything went digital, right? So, I mean, almost overnight, they were gone. So we have to have a way to price in this default risk because the payments aren't necessarily guaranteed. All right, worth pointing out here, when you calculate that yield to maturity on the bonds, that's the rate of return that equates the current price to the promised future payments. If those future payments are in doubt, right, you might not receive some of them, right, or they might be a little bit late, then the actual yield to maturity that you calculate doesn't necessarily mean you're going to get it. Right? If you never receive those future payments, then that yield that you're going to receive is going to be a little bit lower than what you calculated. Okay, so how do we do this? There are companies out there that rate companies for credit, just like you have a FICO score, right? You have a credit score that quantifies for lenders the amount of risk. Companies have the exact same thing. We have Standard & Poor's, we have Fitch, and Moody's are the three big ones. Right? I mentioned Standard & Poor's and Moody's, Fitch is in there as well. And they rate bonds with a score that's very much like your numerical credit score, right? But they use letters instead. And there are all sorts of subdivisions within these as well. When you see AAA like this, whether we're talking about Standard & Poor's or Moody's, Fitch uses something very similar. The way investors will say that is AAA. Right? So AAA rated debt, this is the highest credit quality. They carry the smallest degree of investment risk and are generally referred to as gilt-edged. That is, this is the best that you can get. They're risk-free. As of 2009, there were only 6 public firms that carried a AAA credit rating, and there are fewer now. In fact, the U.S. government doesn't have a AAA credit rating. By one of them, I think it's Standard & Poor's at the moment. So this is very, very rare, and you have to be in good financial health. As you take away letters, you're walking down the credit ladder. That is, you're increasing risk, right? But anything from AAA down to BAA or BBB, depending on what rating you're looking at, is considered what we call investment grade. That is, this is a good credit risk. In all likelihood, you're going to get paid in full and on time by one of these companies that have this credit rating. Okay. The next rung on the ladder, though, is when we get to what we call speculative bonds, and that's the nice name for it. You'll hear these referred to as junk bonds most of the time. Right? These guys, starting with BA or BB and all the way down, these are, oh man, we're not really sure. Right? We don't know if you're going to get paid back. If you look at the top rung here, like BB or BA, you're probably going to get paid back, but some of the payments might be late or a little bit incomplete. Right? But you probably get something back. The further you go down, the less likely it is that you're actually going to get repaid. Right? As you might imagine, the rate of return that the investors demand to hold these bonds goes up as you increase credit risk. Just like if you have a worse credit score, you're going to have a higher interest rate required on your loans, right, to compensate the lender for that risk. And the market does the same thing to companies. Okay. The difference between investment grade and speculative grade bonds is a big one because there's legislation in place that keeps things like pension funds or retirement investment accounts from investing in anything except investment grade. Once you get below that, the largest institutional investors on the planet cannot hold your debt anymore. So it's a significant chunk of the market that does not have access to your debt. Okay. All right, we saw in the example problem for treasuries, we plotted out a yield curve, where a yield curve is just a schedule of interest rates for different maturities. We can do the same thing for corporate bonds. All right, we can plot the yield curve, that is the different yields required at different maturities for corporations. And what we're mostly interested in when we're looking at the corporate yield curve is the spread. Right? And the spread is nothing more than the difference between a risky corporate debt and a similar risk-free government bond. All right, so here's a picture to get an idea of what we're looking for. When we map it out like this, we usually call it a yield curve. If we put it in a table, a lot of times we call it the term structure, but they're both talking about the same thing. Okay, what we've got on here is on the x-axis, we've got the time to maturity. So we have bonds that range from a quarter of a year up to 5 years, 10 years, 15 years, all the way out to 30 years, at different maturities. On the y-axis, we've got the yield to maturity that the market is demanding on those bonds. Okay, the very lowest line, this blue one here, is the U.S. Treasury yield curve. Okay, so for a 5-year risk-free U.S. Treasury yield curve, the market is demanding, I don't know, 1.2-ish, 1.3%, somewhere in there. Okay, so if you were to buy a 5-year U.S. Treasury security, you would earn 1.2, 1.3%. For a 5-year AA rated corporate bond, so there's a little more risk inside of there, you're going to get paid closer to 2%. Right? A little bit more risk, a little bit more yield demanded. If we step down to BBB, which is the lowest rung of investment grade, the market's wanting closer to 3% for those. And that's the typical relationship you see. As the credit risk increases, the spread increases. That is the difference between the Treasury yield curve and the yield curve for the risky corporate debt. Okay, using this is ridiculously easy. All right, let's see. Let's look at number 20. And this will be the last one, y'all. All right, so looking at the example problem, so we have the same numbers for number 20. It says a BBB rated corporate bond has a yield to maturity of 15.2%. A U.S. Treasury security has a yield of 13%. Those yields are quoted as APRs with semi-annual compounding. Both bonds pay semi-annual coupons at a rate of 14.1% and have 5 years to maturity. All right, we've got questions A, B, and C. A is what is the price expressed as a percentage of face value for the Treasury bond? Okay, so for the Treasury, let's map out the cash flows that we know. All right, this thing's got 5 years to maturity, but it's making payments semi-annually. So we've got 10 total periods we're looking at. Let's see. Both bonds pay semi-annual coupons at a rate of 14.1%. All right, so before I go to calculate that coupon payment, I need a face value to do that. It wants the price as a percentage of face value. Okay, so what face value should I pick? It doesn't tell me one. I could use 5,000. I could use 100,000. If I'm eventually going to convert it to a percentage of face value, I can use 100, right, and get it to come out with a number I already want. All right, so let's say to get the price as a percentage of face value. All right, so knowing that, my coupon payment is the coupon rate. Was it 14.1%? Yeah. All right, times the face value, and I'm going to divide that by the number of coupon payments per year. So that's 1410, so 705, right?
Where did the
Even I start getting a little punchy after 2 hours.
come from?
Ma'am?
Where did the 0.141?
Oh, good question. All right, so it says both bonds pay semi-annual coupons at a rate of 14.1%. So that's my coupon rate. Oh, that's silly. Oh, well. Yeah, 705. Okay, so for the Treasury bond, per $100, we're going to receive a coupon payment of $705. And then with that last coupon payment, we're getting $100 back. It wants to know the price, so we need to discount all of these cash flows back to time period $0 using a yield of 13%. And that 13% was given to us in the problem. Treasury security has a yield of 13%. All right, even I'm falling asleep up here talking, so just to wake you guys up, what's my n going to be? 10 total periods, right? What's my I over y? Yeah, 13 divided by 2. Awesome. Whoops, so 6.5. Present value is what I'm looking for. What about my payment? 7.05. And future value? 100 in this case. Awesome. Just for the sake of consistency. All right, so I got a price of $103.95. So it's trading at a premium. Does that make sense given the information in the problem? Should it be a premium? The yield to maturity is 13%. That's less than the coupon rate of 14.1%. So yeah, it should be trading at a premium. We're okay. All right, so Part A, the price as a percentage of face value is 103.95%. Right, because we assumed a price of $100 or a face value of $100. So 103.95 divided by 100 is 103.95%. The beauty of picking that 100 is we get the answer just as we need it. Okay, it wants to know the price as a percentage of face value for the corporate bond. All right, for the corporate bond, they both have a coupon rate of 14.1%, but the yield to maturity on the coupon bond given to us in the problem is 15.2%. Triple B rated corporate bond has a yield to maturity of 15.2%. All right, so everything else is exactly the same with the corporate bond. All right, it's making 10 total payments. Coupon rate is the same, so it's making the same $7.05 payment per $100. We're still looking for the price, so we need to discount all of these cash flows back, but now we're going to discount them back at 15.2%. All right, so our I over Y is going to be the 15.2 divided by 2. All right, and since I've already got all that plugged into my calculator, on this one, instead of clearing it out, I'm just going to change the I over Y. So I'm going to type in 15.2 divided by 2 equals, and press I over Y to store it, and everything else should still be the same. So let me check. Recall in is 10. Recall payment, 7.05. Call future value, 100. I'm good. So I can hit compute. Present value. Yeah, 96.24. Right, and with this one, the yield to maturity is 15.2%. That's greater than the coupon rate of 14.1%. So I expected a discount. That checks out. So that bond is trading at 96.24% of face value. You guys getting the same numbers? Yeah? All right. All right, this very last question, question C, is what deals with the credit spread. And question C is, what is the credit spread on triple B bonds? The spread is just the difference between the risky corporate debt and the risk-free government debt. That's all it's asking. So it's the difference. It's the yield to maturity of the corporate debt minus the yield to maturity on the government debt. That's all it's asking for. All right, so the yield on the corporate debt, it told us was 15.2%. The yield on the government debt was what, 13%? Was it 13.2? 13, okay. All right, so the spread then is 2.2%. That's it. So a corporation, in order to sell an investor the exact same bond the government sold them, is going to have to pay an extra 2.2% to get the investor to hold it because of that extra risk. That's all it's asking. That's all it's saying. All right, so that'll give you the mechanics to look at all of the homework problems from Chapter 6. Everything that you're asked to do is going to be sort of a different angle of something that we've looked at. You will save yourself, I promise, an awful lot of time if you go back and read through this chapter with some attention before you try the homework problems. All right, so give those a go. If you have questions on the Chapter 6 homework problems, which I'm sure there probably will be, throw them up on the discussion board and we'll answer them up there as they come up. And of course, you guys have access to me as well over email or text or whatever. If I don't talk to you before, I will see you guys on Thursday for stocks. If I don't talk to you before, I will see you guys on Thursday.